Alright, so this is our 6th week. We've covered analytics, we've covered visualizations a little bit, we've covered descriptive statistics, sampling, data integrity, confidence intervals, and that intro to hypothesis testing. We've done one sample hypothesis test. Right, so we've had one sample, and we compared it to the mean, and that's where we ended up last week. This is what's on your exam. This is it. 5 weeks of theory. Seems a little light for a midterm. Good. He's like, no, this is great. This is fine. You don't need to put more than that. These 5 lessons are what's going to be on your midterm. Do you have any burning questions that we need to address before we get into the exam review? That's where we're going to start. My plan for the exam review is just to give you kind of an overview of what I plan to have kind of the style of the exam. Hit the main topics that I plan to have on the exam. And if you have any questions about it, stop and ask, and I'll go into more detail. So, midterm details, Wednesday in class. Okay. So next Wednesday in class, we'll start at 8:45. Okay. So that gives the crap, parking, whatever, there's a little buffer. Okay. Any last minute questions that we have after you've studied for a week, any last minute questions, we'll answer those. Give us time to get in, get set up, all of that. So at 8:45 we'll start. Currently I have the test scheduled to last for an hour. I don't have the test written yet. I have an outline of it, but I don't have it written yet, so I haven't run through it yet. If it's longer than I think it is, then I'll give you 75 minutes. Okay, so I'll make sure that you have plenty of time to complete the test. It'll either be an hour or 75 minutes, which means we'll still have the second half of class where we'll do independent t-tests. Okay, so we'll test in the first half of class, learn new stuff in the second half of class. Test composition, they're going to be a lot like your quizzes. Okay? Multiple choice, true, false, fill in the blank, short answer. Mostly covering concepts. There will be some questions about SAS. You will not be, I decided not to have you actually use SAS for the exam. That's what I did last year. It blew up in the face. Students didn't really like it. There was lots of complaints. So instead, my plan is I'm going to either give you a scenario and then give you multiple screenshots for your options. And you will pick, this is the option that I would go do in SAS. All right, so you won't actually execute it. You'll just tell me, this would be the thing that I would do. Or I'll give you, instead of you having to create the SAS output and then analyze it, I will give you the SAS output, and you just have to analyze it and answer some questions about it. So knowing SAS is important. Utilizing SAS, not as important. Fair enough? Academic integrity, because we like that. It will be conveyed to you on Blackboard. Do not retain any part of this midterm for your personal records, i.e. don't take screenshots as you're going. You're probably not going to have time to do that. But either way. This one doesn't apply to you guys quite as much as it applies to my Saturday class. Don't talk with anybody during the test. Seems obvious, but you'd be surprised. Personal student notes, including any information found in Blackboard, are permissible during the midterm. So what does that mean? PowerPoints. PowerPoints, sure.
Personal notes.
Personal notes, sure.
What about
it means that you're going to make sure you don't have time for them.
Yeah, basically. So it's an open book test. That's basically what it's saying, right? It's open book, open note, whatever. Okay.
How many questions?
30-ish. I don't have it officially finished, so I'm not sure, but 30-ish. And it's one of those, it totally depends. Like, there could be 10 questions, but each of them have 3 parts. There could be 30 individual questions, but 30-ish answers. But yeah, so you do have your notes. You can use whatever you want. My biggest recommendation to you is to go ahead and, like, pretend that I'm only giving you, like, 1 or 2 pages of notes and kind of, like, create a study sheet, a cheat sheet, if you will. Yeah. And have that at the front of your book, or the front of your notes or whatever. So, like, that's the thing. Like, if I really have a question, that's my go-to first. And then if she asks me some really crazy, obscure question, then I can go look through the rest of my notes. Right? But I would encourage you, because it is going to be an hour test, probably. It's going to be about 30 questions. I mean, it's going to be a fairly rapid test. The way that I design it is that you guys should have the opportunity to look up about 3 questions. It's kind of the way that I try to structure it. I make sure, I have several people take the test before you guys get to it. So I have times to make sure that you guys should be able to accomplish it. But yeah, that would be my one big thing to encourage you. Would be like, go ahead and like make a note sheet, a cheat sheet kind of, and have that kind of at the front. That's like your first go-to, and then you have your book. The only thing that is not allowed during the test is searching for information online, right? So you can have anything you want to ahead of time, but once you get into the test, no more Google. Fair enough?
Textbook.
Yeah, you can have a textbook, you can have whatever you want. Let me rephrase that. You can have whatever you want that fits in your space. You got a pretty full class, whatever you want that fits in your space, that is yours, not someone else's. You guys are going to do anything crazy on me tomorrow or next week. So any questions about the details? Yes.
Is it like one of the tests wherever you submit it shows you your grade?
So it will show you half your grade,
Okay.
because it'll show you the ones you got right and the ones you got wrong. But if there's short answers back a grade, then it will show the whole thing. But yes, you will get to see all the multiple choice that you got right and wrong. I think. Technically, I can turn that feature off. So, that'd be cool. So, that's one of those. So, I learned from last year that I should turn that feature off because bad things happen. But now I'll probably leave it on because I don't expect major issues here. So, yeah, so you'll get to see your grade up into the short decision. Other questions? Alright, my plan for exams is pretty straightforward. I love to make homework hard. I will put tricky things on homework. We'll discuss one of those tricky things here in a minute. That's on assignment 4. So I don't mind having tricky things on homework because you have time to think about it. I'm not a huge fan of tricky things on tests. Okay? If it seems that easy, it is that easy. People laugh. But seriously, like my testing style, if it seems that easy, it is that easy. Don't overthink it. Okay? Examples of things that we could have. Right, key points from lesson 1, we talked about business questions and analytics questions. So, short answer kind of questions, I could give you a scenario and ask you what business question. Right? I could give you a business question and ask you what would you do in SAS to find the answer to this question? Okay, or what analysis would you run to find the answer to this question? Scale of measurements. There's a good chance I could give you a variable, multiple choice. Is this a categorical or a continuous variable? Is this a nominal, ordinal, interval, or ratio variable? And I'm going way back to week 1. You good with that? Lesson 2, we talked about visualizing categorical data and visualizing continuous data. examples of questions could be, given a frequency distribution, answer a question about it. Given a cross tabulation, answer a question about it, similar to what you have on your quizzes. I mean, questions could be as simple as, given a scatter plot, identify what's on the x-axis and what's on the y-axis. Right? Which two variables does this scatter plot talk about? It could be interpret a scatter plot. What is the relationship between these two variables? If you have a question, what's the difference between a histogram and a bar chart? So I'm just throwing questions out. If you know the answer and you're feeling comfortable, great. If you have questions about a question that I ask, feel free to ask, and we can go further down. Those are just kind of some ideas. Maybe I give you a box plot and ask you to interpret something from that box plot. Okay. I could ask, what elements go into creating a box plot? So there's lots of different ways to ask questions about this. More key points from lesson 2. We talked about measures of location, variability, distribution, measures of relative location, and detecting outliers. I'm glad you guys are typing crazy. You do know these are available to you, right? Okay. Please type crazy all you want. I just want to make sure that. Questions can range anything from how do percentiles and quartiles relate to each other? What's the difference between the variance and the standard deviation? Oh, you're just talking. Okay. Given a distribution, tell me the skewness. Is it skewed to the right, skewed to the left, not skewed at all? Given 2 data sets, which one has the larger range? Given a box plot, can you identify the outliers? Fill in the blank question or short answer question, what are possible ways to find outliers? The stuff I'm trying to ask really, when I say keep it simple, and it is that easy. I know easy is a relative term. Easy is a relative term. And in fact, as I was grading some of your assignments, I even put down, don't use judgmental language like clearly and obviously and of course. And here I am saying, easy, no problem. At this point, everybody's smiling at this point, so I feel like easy is doing anything. Straightforward. How about that? That's probably better way. Straightforward. Alright, any questions about lesson 2 stuff?
Was the cross tabulation where it was 2 variables, like the 2,
yes.
like chart? Okay.
Yes. Simpsons paradox. The Simpsons paradox. Okay. Yeah. So the quiz question about the golfers, that was the cross tabulation.
Are you going to ask us fast brain question?
No. I'm going to make sure that it is a scenario that everyone would be very comfortable with. Yes. I've learned a lot as I've been making quiz questions. I thought I was trying to be fun and incorporate things people like.
It's kind of an extrapolation,
Other classes.
an extension of quiz.
Yeah. It's basically, it's the quiz on steroids, if you will. Right? So instead of just 5 questions, we're going up to 30 questions. I've added the SAS component. So like the SAS component on something like this, I could give you like SAS output and ask you to identify the mean median mode. I could give you SAS output and like I was saying, like the box plot, like can you identify the outliers from the SAS
Interpreting the SAS output.
Yeah. So that's something that hasn't been on your quiz, that you can do it in your homework. But that would show up on the test as different. Yeah.
Will there be anything as far as like actually working in SAS, so screenshots of what we actually go through and,
There could
check
be.
and select to get a certain output, like
There
going
could
through
be.
doing a confidence interval or something like that.
Yeah.
Which of these screenshots gives you correct?
There could be, yes. So, for example, and I have some software stuff here in a little bit, but like an example, like a confidence interval would be perfect, right? So I could give you the screenshot. Let's say we're trying to find the confidence interval of a mean, and I could give you a screenshot of you went through the descriptive statistics, right? So we've described, we're in the summary statistics, we're in the additional information, and I have something clicked or something not clicked. If I ran this now, would I achieve whatever the objective is? Right, so I could ask a question like that, or I could ask a question potentially like, here's a scenario, and I want to get descriptive statistics. Would I use the one-way frequency, or would I use the summary statistics to analyze this variable? So if it's a continuous variable, you would say summary statistics, and if it's a categorical variable, you would say one-way frequencies. So you'd have like screenshots, like here's option A, here's option B, which one would you pick? So I haven't made it yet, so I'm not exactly sure I'm going to do it, but those are kind of the ideas that are floating around my head. I did just do one for, you can see it yet, but for quiz 6, which is what this will start to be modeled after, I've done those two things. Like, here's a scenario, it's like, in which, so now that you're on the screen, what would you click? And it's not like crazy weird things, it's like the big obvious things. Other questions? So from lesson 3, we focused on data cleaning issues. Not quite so many questions I'm going to ask you about that. Sampling, so knowing the difference between a population and a sample. So if I give you a scenario and ask you, and give you, a multiple choice of choose the population, you should be able to do that. Great chance you're probably going to see a multiple choice question where here's a given scenario. I'll try to make it a very obvious scenario. And you'll get to pick which type of sampling method was used. Yes.
Can we have an optional explain box? It's not needed to be filled, but in case there's a confusion, you at least say what you think about it.
You can't because Blackboard isn't set up like that, so it doesn't give you that option, or else yes. But since you will be taking it in class, if you have a question, I can go talk to you and clarify it. Yes.
Another kind of Blackboard related question. I see that the quizzes are still I can still there's still a begin button. If I were to go back and try to go through the quizzes again with that, could I do that? Or because as soon as once you submit, you can't go back and see the questions that were asking about you.
You can now.
You can now.
You can now. Somebody do it. Go to your grade book. And when I say you can now, I hope you can now. Well, because I can't see what you see. There's some things where I can see the student view, and this is the one thing that I can't. So if you go to your grade book, and so over to your grade book, click on a quiz.
Oh, yes, you can.
Nice.
Okay, great.
Thank you, Dr. Keeper. Okay. So then you click on the quiz itself, and then over on click on the name of the quiz. This is like a weird part, right? So you click on the name of the quiz, and when you do that, it comes up and it just tells you your grade. And then over on the right side, it looks like a number, and it doesn't look like you should be able to click on that number, but if you click on that number, it'll actually let you into the quiz.
It's very slightly differently colored.
It's very, yeah, it is like you shouldn't be able to click on it, but you can click on it, and now you should be able to see the question. You should be able to see all the answers. You should be able to see your answer. The only thing I didn't let you see was the correct answer. So if you can't figure out what the correct answer is, send me an email, talk to a friend. The one thing that the only thing that I ask in letting you see all this now, because I feel like it's fair, so you can study better. Please don't share this with next year's students. That's the only thing I ask. So giving you this access now, the only thing that I ask is that you don't share this with next year's students. Obviously, there's questions I'm going to be changing. Occasionally, there's a couple of good ones I don't want to have to change. So it's my only request. Other than that, have fun. You should be able to see everything that you need to see. Does that help?
Yes.
Awesome. Other questions? Alright, so sampling questions. You need to know the big picture behind the probability distribution. We've had a couple of questions on your quizzes about that. Alright, so just the big picture of, it looks like a bell is normally distributed. 50% on each side is symmetric. We can use it to find all sorts of cool stuff. You won't see questions exactly like on your quiz, and for here, maybe a question about the probability distribution is not going to be a focus. That was one of the key points from that lesson.
Somewhere else, typically the answer could be short and very straightforward, but the questions could be long. Would that be the case? Because that could be time consuming.
They're not going to be like crazy long. I mean, there'll be a couple that'll have some scenarios that go to them, but generally that's going to have like 2 or 3 questions that will be answered with the one scenario. Most questions will be pretty quiz-like as far as length. So, but like when I had the golf question, right? There's a little bit more of a setup. And so if I do something like that, you'll probably have like a little bit more of a setup. And then that'll probably be one of those where like I give you the results. So you need that little bit more of a setup to interpret the results. And I may ask you like, what is the null and the alternative hypothesis for this question? And what is the p-value? And what is the test? So I'm going to get like 4 or 5 questions out of that. Yeah.
Or the GRE mapping.
Yeah, not like that. Alright, lesson 4, we moved into confidence intervals. So knowing the difference between a point estimate and an interval estimate. Alright, that's going to be important. Being able to interpret a confidence interval would be important. Not in a crazy, Dr. Keeper messed up the quiz question kind of way, but in like a real, legit kind of way. Knowing what your margin of error is. Alright, so here's places where I could, like, kind of what Tim asked, I could give you, like, here's how you would create a confidence interval, or I could give you the output from a confidence interval. I could ask you a question about that confidence interval. And again, when I say things that could be simple, I could give you an output from SAS and just ask you, what is the confidence level for this output? It says right there in the box, like 90%, 95%, 90%. It's that easy. Okay? I mean, like, I do put those kind of questions on there. It's really just a, can you see, do you understand where it's coming from? Okay, you don't have to do anything special. Anyway. Questions about confidence intervals? Last thing we talked about, and if I had to say proportionately, because this is a question somebody will ask me in a second, not a whole lot of questions from lesson 1. And again, I haven't made the test, so I can't give you an exact breakdown. Probably not a whole lot of questions from question 1. Probably quite a few from lesson 2. Probably just a couple of questions from lesson 3. I mean, I know this is very vague, but there's going to be a few more from lesson 4, but there can't be too many because there's really not much that happened in lesson 4. It was point versus interval estimate and confidence interval. Lesson 5 there's a lot of meat in lesson 5. So I would say probably like 35. Let's see, if it was even, everybody would have 20%. So I'd probably say like 35, 40% of your test could come from lesson 5. So fair disclosure. And it really is because there's just so much meat here, right? We can talk about the null and alternative hypothesis. We can talk about tests being one-tailed, two-tailed, directional or non-directional. We can talk about type 1 and type 2 errors, right? So questions could be, I give you a scenario and I ask you to write out the null and alternative hypothesis. I could give you a scenario and I just ask you to choose multiple choice style. I could give you a scenario and ask you to identify the type 1 and type 2 errors. I could give you a scenario and maybe even tell you what the type 1 and type 2 errors are and just ask you from an ethics perspective. Technically I didn't have ethics in lesson 1, but ethics in lesson 1. I could ask you from an ethics perspective which one's worse and why. Alright, so here's given a scenario. We can talk about this today. Alright, so like given a scenario, when we talked about this last week, I don't remember, maybe Jacob, were you the one who was kind of talking about like the jury as an example for hypothesis testing? Yeah. So we talked about like pregnant, not pregnant, right? So we could talk about, it could be a scenario about positive test results, negative test results, or there could be an example like from a jury perspective, right? So which is worse, a type 1 error or type 2 error? From a jury perspective,
Probably.
Type 2 would be letting a guilty person go free, right?
okay, so what would, so from a jury perspective, what would a type 1 error be?
Convicting an innocent person.
Convicting an innocent person. And what would a type 2 error be?
Not convicting a guilty person.
Not convicting a guilty person. So which one's worse?
Depends on the crime.
Type 1.
And that's the ethical question, right? And so this is where one of those, when I ask something like that, as long as you're statistically sound and telling me, well, a type 1 error would be this, and this is why I think this is worse, as long as you got the statistical part, the ethical part, as long as you can argue it with me, I'm okay. Right? So when it comes to questions like that, yes, I know there can be multiple answers, and I will grade that way, don't worry about it. As long as you get the statistical part right. And same thing happened when I was grading. So I graded assignment 3. I'm most of the way through assignment 2. I will have assignment 4. This is going to be the fun one. I'll have assignment 4 graded for you before Wednesday. So you guys will turn it in, and I will have it be the fastest one I ever graded. So I'll get it to you so you have it for the test. But I was going somewhere with that. Yes.
Are you still planning on extending that, or?
Yes.
Sorry.
That's right. Yes. Which makes it harder.
Right.
So, going somewhere with this, type 1, type 2 errors, one could be worse, one could be, I grade appropriately, because on assignment 3, I get there. On assignment 3 that I graded, they were very subjective questions, right? Would this be a good place to advertise for online brokers? Would this be a good place to advertise for education? Okay. Obviously, question 6, which was what kind of articles would you recommend, that was wide open. Okay. But even for the first 2 questions, so if you remember, show of hands, how many said it would be, so Heavenly Child, or no, the Young Professional Magazine would be a good place to advertise for online brokers? Do you remember? Did you say yes? But some people are like, I didn't say yes. What about a good place to advertise for children? How many say yes? Again, look around. Not everybody said yes. Okay? So some people said yes, some people said no, and as long as you had the statistics to back up your story, you got credit. Right? So it wasn't that there was a yes or no answer here. It was, do you have the statistics to show why this would be a good idea and why this wouldn't? right? So if you only looked at, for the children, for example, right? If you only looked at the proportion of people that had children, and you based your answer on that. Sorry, slight detour, it's working. Then everybody's like, oh, over 50% of our readers have children, it's a good place to advertise for children. That's an okay answer. Okay. Some people are like, okay, well, we've got this percent with children, and this percent with broadband, kind of separately. And you look at it separately, and you're like, well, the majority have children, the majority have broadband. Great, let's do it. Okay. Then I had some people that said, okay, let's look at, of the people who have broadband, what percentage of them have children? Right? So now you're segmenting a little bit more, and if you segment a little bit more, now you're down to like 34% of the people with broadband have children. Some people still claim that, that's a third of your readership. Sure, it's still a good place to advertise. Why wouldn't we want advertising dollars? Some claimed at that point, no, that's probably not where I'd be going. Some people took it a step farther and said, not only am I going to look at if you have broadband and if you have children, but I'm actually going to look at your income. And when you start to do that, you'll notice that the people who have broadband and have children have less disposable income, have lower, I don't know the other way to say it, based on our data, have lower median incomes than the people in the other category. So now you're assuming that these people have less money to spend. Maybe this isn't, right? So now you've gotten to know. So depending on what data you use to support your answer, you may have said yes or you may have said no. Give you credit either way, as long as you had a good statistical reason for making your conclusion. Same thing happens here with the type 1 and type 2 errors. All right, if I put a question like that on the test, it is an ethics question. Right? From the defendant's perspective, whatever outcome has me going free is the one that I like. Right? So type 1 error would be worse. From society's perspective, is it worse to put somebody innocent in jail, or is it worse to let a potentially, murderer or killer go free? Okay. Doesn't matter what the crime is. Is a type 2 error worse if we're letting murderers go free versus if we're letting somebody who has a traffic violation go free? So it all depends. And all we have is just, we can use our statistical evidence to support our claims. So you see why I don't ever use the word proof? I'm not going to prove that this is the right answer, this is the wrong answer. I just have support, statistical evidence for my answer. Alright, so type 1 and type 2 errors. So I could just ask you flat out, what is a type 1 error? I could say, here's a scenario and select the type 1 error, or type 2 error. I'm not going to have you do what you do on your quiz where you had to list the 6 steps. Is that question? I mean, I think everybody got it right. So, I haven't looked yet because you guys just turned them in, but everybody in my Saturday class got them right, so I'm pretty sure you guys can copy stuff out of the textbook. But it is important, and we are going to use those 6 steps for the rest of the semester. Okay? So I wouldn't have you directly do that, but I might ask you a question such as, given the p-value approach to hypothesis testing, when do I reject my null hypothesis? This is a fun job. Right, so when my p-value is less than or equal to my alpha level, and that would be one of the ABC options. So I'm going to actually have you do step 1 percent. I could actually, that being said, I may give you a scenario, I may give you output, and I may ask you to state the null and alternative hypothesis. I will give you step 2. I'll always tell you what the alpha level is on a test. Step 3, I may ask you what is the test statistic, and you would get that from the output that I give you. I might ask you what is the p-value, and you would get that from the output that I give you. I would ask you what is your statistical conclusion. Right? Reject a null hypothesis or fail to reject a null hypothesis. And then potentially an open-ended question of, well, how would you interpret that? How do you take your statistical conclusion and turn it into a business practice? So that's one of those where you may have a bigger setup, because I may get 6 questions out or 5 questions out. And so then the thing that we learned was we did a 1 sample t-test. So we had 1 sample mean, we were comparing it to a population mean. And this is where we ended last week, and we'll talk a little bit about it this week. And then we had 1 sample proportion, and we were comparing it to a population proportion. And so that's what we were doing at the end of lesson 5. It was a 1 sample test. We had 1 sample of data, and we were comparing it to a given value, a given population value. That's as far as we'll go here today. Questions, comments, thoughts about what's going to be on the exam, what we've done for the last 5 minutes? Yes.
So what about the questions like, how do you interpret the confidence interval, like you had in the assignment 3?
Mm-hmm.
So how do you interpret the given confidence interval? I mean, you have to derive the confidence interval and interpret something from it.
So 2 different things. And so if you guys have looked at your grade for assignment 3, first of all, well done. I mean, all A's and B's. It was great. One of the big things that I took off for was you could go in and you did, like you executed, finding the confidence interval. You even accurately, statistically interpreted the confidence interval. But you did not provide any insight from the confidence interval. And so that's where I took off. A lot of people missed like half of it. So like the question was worth 2 points, you missed 1 out of the 2 points. So I think that's where you're going?
Yeah.
Yeah. So the interpreting, most everybody got like the actual interpreting, like statistical interpretation. Well, the insight would come from, so you have the average age is 30. And the confidence interval was extremely small, right? It was like 29 point something to 30 point something. Like it was a really small confidence interval. So that's telling you that here's my average, small confidence interval, my average age is really my average age. So you could either get insight from, that's the age we're targeting, right? So in the scenario, it tells you that was the age we're targeting. You could get insight to there's not a lot of variability in our readership, right? Most of the people who read our Young Professional magazine are around that age. So you just give like kind of like that next step. Like how can we actually get insights that we could use to do something with? So not just a confidence interval that says, well, I'm sure my true population mean is between this and this. That's great. But so what? So I was looking for more of kind of the insights. Some people, let's say, what was the other question? It was about like broadband. Yeah, like broadband and children was the other one. Right, so you did a great job. You got like calculated, stats was great, interpreted statistically the confidence intervals between this and this, but then, so what? So I was looking for that interpretation, that insight, right? So there's a difference between interpret the confidence interval statistically and then provide insight that you would get from that confidence interval. So that insight could be anything from children. We think the majority of our people have children, but when we start to look at the confidence interval, that may not be the case, right? Because the confidence interval actually dipped to under 50%. So you can get insight to that. You could give insight to the broadband of the 60. It was like the point estimate was like 60-ish%. You had more. The entire confidence interval was above 50%, so you can be very safe and say that the majority of our people are looking at or have broadband access. Since we're an online journal, this is a great way to continue pushing more of our products because more of our students or more of our readers have broadband access. We should be putting more of our content online. So it's just kind of like, what is that next step that you take? Does that help? Make sense? Questions? And that's just the me pushing you. You guys are really good at the stat part, but now it's trying to think that business piece. Think, where can I take that next step? And we'll start practicing that more. So the first half of the semester is a little harder for me to teach, just because you can't dig in and get really rich with confidence intervals too much. once we start this independent t-testing and the regression stuff, the business questions get richer, the interpretations get easier and better, because you have more context, you have more to talk about. You can talk about descriptive statistics and the statistical test and there's more to talk about. So this part will be easier. So questions, comments about what you're doing or saying?
Just sticking to that particular scenario of broadband and children.
Okay.
Typically, I mean, from a real world perspective, I may look at the data and say that there's a large population which have children, but there's less of broadband. But I could use the advertisement as being sort of luring them into a broadband plan. But would that qualify for the exam?
Yes, absolutely.
For academic purpose.
Absolutely. So someone could say, like someone could have, like I was saying earlier, right? So when you break down the broadband and the children, you get that 30%.
Yep.
Right? So somebody could be like, it's only 30% of our readership, this would not be the way that I would do it. Or somebody may take that as, well, only 30% of our readership are fitting this, so I think this is actually a great place to advertise and see if we can get more of our readership interested in X.
Same thing with, I think, broker also.
Mhm.
Like I interpreted it as too low given the stats, but then it could be used as a potential.
Other people said it was great.
Yeah.
And
It's an opportunity.
yeah. So it just kind of depends on how you're looking at it. So as long as you use the statistics to support your position, and as long as they're accurate statistics, then you can use the statistics to support two different positions. It's the same thing that's going to happen when we start to get the sample proportion. Right? So when we start talking about proportion, we can look at the proportion of people that have it, or the proportion of people who don't. Right? So if you focus on the proportion of people who have whatever, then you can be going in more of a positive direction. Whereas if you focus on the proportion of people who don't, now you're going in a negative direction. So you can choose, and they're both statistically accurate, which message you want to send. Right? So this is the storytelling part. Right? So statistics are statistics. Everybody says you can lie with statistics, but really you can't. Right? The statistics are what the statistics are. You can't change them. But the story that you tell with them can change. And that's where you've got to be careful, right? And not careful, just ethical. Right? So if the answer is, so if I wanted to say, yes, I want to bring that person in because I know they're going to bring in ad revenue to sell like the educational toys or educational software. And I'm looking at it, well, this is how many people have children and they've got broadband, and look, this still has 30% of our customers. We should totally add that for that segment. Whereas if I was going the other way, now I'm talking about the fact that there's 70% of our people who don't have children and don't have broadband. Why in the world would we try to bring those advertisements in? Right. So the exact same statistic, but depending on the story I want to tell, I can use different values. Does that make sense? Has anybody taken a marketing class? Has anybody been subjected to marketing? Yeah, commercials, TV, print, Facebook, whatever. Those are kind of the things to think about. Right? It's true, the statistics there, but it's the story that you want to tell and convey. And so that's where, for me, as long as you support things appropriately, I'm happy. Now, if 28 people say no and one person says yes, you're going to have to argue pretty strongly. But if you can convince me, then you can convince me. So yeah, there is a right or a wrong. When I ask you for a p-value, there's a right or a wrong. When I ask you for an interpretation, there's not necessarily a right or a wrong. I think that's the best way to say it.
It's the same thing with reading the statistics, that's pretty much given.
Right.
But then
The mean is the mean. You can't change it. But how you interpret that mean and how you use it to make your points, that you can change. And that's kind of how the test is going to be more objective, right? Tell me this, give me this, and then there'll be a few subjective depending on how you read it. Okay, but the test for the most part. Your homework, when you start to do your project, as you write your executive summaries, those are more subjective. Again, statistics are the statistics. Those aren't going to change. If everybody's using the same data, everybody's going to get the same p-value. That won't be the case next semester in the data mining class. There is no answer key for data mining. Here, there's still an answer key. Alright, so any questions about content that you can see on your test? The last thing I went ahead and made a few slides about the software, about SAS, just because I told you some SAS was going to be on there. And really, kind of the things that you would see would be like descriptive statistics. If I gave you a categorical variable, you'd use a one-way frequency. If I gave you a continuous variable, you would use summary statistics, combine the descriptive statistics. Right, by now, hopefully that's kind of second nature to you. You're kind of knowing where to go. I'm not going to ask you to go do something crazy obscure on a test. The data prep, data cleaning, right, from lesson 3, filter, sort, right, so that could be a question. Right, so given this scenario, if I'm only interested in males, how could I get a data set that only contains males using SAS? Right, you can use the filter option. I'm not going to, I could. Look at me coming up with questions. Right? Okay, this is more one of my evil genius ones. Right? I could theoretically, because we've had so much fun with it, give you a screenshot of the query builder, and I could ask you, what's wrong with this? I feel like the probability of that question is very low. But I'm trying, I have to give you like questions that I won't ask, because I can't just give you any better, but I will ask. But the only thing I think like really for the query builder could be something like, given this situation, or maybe I'll set up like 3 or 4 cases and ask you what's the next case, right? So we have, like as you're creating intervals for age, right? If I show you that I've already created the interval from age 10 to 19 and the interval from age 20 to 29 and the 30 to 39, and I ask you what's the next case, you should be able to look at the query builder and say, oh, the next thing you're going to need is 40 to 49. Right, so that could be a query builder question. Again, that probability is kind of low, but for confidence intervals, right? To calculate our confidence intervals, describe summary statistics. In the statistics options, we click the additional, and there's a fun little checkbox for confidence limits. Once you're there, you have to select your confidence level that you're interested in. So that basically, if I take an entire tutorial and get it into 2 lines, that's what it says. For the proportions, we use the one-way frequency. We pick the asymptotic t-test, or the asymptotic test. And then we need to edit the code, or you can use the sort method to modify your proportion of interest, right? So if it's giving yes and you want no, or vice versa, you guys know how to go in and change it now. The last thing, and the thing I'm going to preview real quickly, and this is what we didn't get to last Wednesday, is when we get to hypothesis testing. So one of the things about hypothesis testing, when we're talking about a sample to a population, is we're going to make the assumption that we have a normal distribution. Because if we're going to use our statistical tools, we have to have a normal distribution. So we can actually go check using this method right here. We're going to go to distribution analysis, and we can actually, there's a statistical test, a hypothesis test, to see is this distribution normally distributed or not. We'll do that here in a second. If you went through the tutorials, how many of you guys used the tutorials? I think I asked you this last week. A few more than last week. Okay. You're like, I do when I email you a question and you say, read the tutorial. So the tutorials hopefully should help. So if it's nothing obvious, those should help. The tutorial, when you're looking at one mean compared to a population mean, so a sample mean compared to a population mean, It tells you to go through the describe, the distribution analysis, tables, and there's a test for location. And you can absolutely do it that way. Another option that's going to get you the exact same answer is to do analyze, ANOVA, t-test in one sample. We'll do that here in a second. So there's two options of how we can get to one mean compared to a population. For the one proportion, you've basically already done that. Right? When you do your confidence level, you notice that you get the null hypothesis too, for the hypothesis test as well. The only difference is we haven't necessarily changed what the population proportion is, and that is an option. So hopefully this is just like a summary slide of what you need to do for chapter 5 stuff. And we will do an example. Oh yes, one thing that's really important when you get to hypothesis testing, when you're working with SAS. SAS's default p-value is for a two-tailed test. So if your hypothesis is a one-tailed test, then you have to take the p-value that SAS provides and cut it in half. Let's do an example of this.
Do you also cut the alpha in half?
So
To compare it?
you don't have to cut the alpha in half. So if you cut the p-value in half, you don't have to cut the alpha in half. If you cut the alpha in half, then you have to go, and the only way you do that is you actually, no, I think that died. So if you cut the alpha in half, then the p-value will be correct. So if you cut the, so you have the option, right? So if you cut the alpha in half, then it's going to be, then you're telling SAS, hey, I'm splitting it in half. And then the sum will actually be correct. Let me do an example, I'll show you.
Okay.
Right, so if you use the alpha level as stated, then you have to cut the p-value in half. If you cut the alpha level in half, then the p-value will be correct.
Because the p-value is the total value of both sides.
Right.
So on the homework assignment, do you want the p-value divided by half, or do you want the p-value that SAS spits out?
So I want the appropriate p-value.
Okay.
So whatever that is. So if you're doing a two-tailed test, then what is the homework assignment? Is it two-tailed?
I think it's going to be each. Yeah.
Okay.
Yeah, it's one tail.
So if it's two-tailed, then you're good to go. If it's one-tailed, cut it.
Okay.
Let's do an example. Alright. Before we do that, let's do this real quick. So, I was grading Heavenly Chocolate. No, yeah, I've been reading all yours all day. You guys wrote so much. So I've been in like Heavenly Chocolate's world when I was putting this PowerPoint together last night. So we're going to go back to Heavenly Chocolates real quick. Everybody familiar with Heavenly Chocolates? Yeah. It's been a little bit, yeah. Yeah. So we had the, it was assignment 2. Right? So Sunday through Saturday, we had the day, we had the browser that they used, the time that they spent on the website, the pages they used, and the amount that they spent in dollars. And there's all sorts of business questions that we could ask. Okay. You know, basically just figuring out what do we know about our shoppers. One of the questions was, you know, do shoppers who spend more time view more pages, also spend more money, so we're looking at correlations. How do the day of week affect sales? How do the browsers the shopper uses affect sales? And the question I'm going to start with is going to be, should we make our decisions based on the no, this is a separate question. So should we make our decisions based on the total amount of sales or the average sale per customer? So that was a question. And then going a little bit deeper, is there a difference in the average amount spent by this sample of customers compared to our store average of $60? So this is the question that I want to tackle real quick. Is there a difference in the average amount spent by this sample of customers compared to our in-store average of $60 per customer? So. I did not already get this set up. I apologize. I'll let you guys get into Enterprise Guide. It's going to take me a second to get this going. So how are you guys doing with assignment 4 that is due tonight?
It's not too bad.
Not too bad?
At least as of right now.
Better question. If you had to turn it in before class.
No.
I know, right?
You don't want to see that.
Okay. Okay, better. So as of like right now, as of 9:30 right now, how's assignment 4 going?
There's only one part that I
So one part we don't understand. It's going. I just haven't really done it yet. It's not due till midnight.
You get a lot of names if you pick it up now, so that's good.
Just what?
You just get the names if you pick it up now, so that's
Oh, so yeah. So it'd be easy to grade. So yeah, easy to grade.
Just have zeros.
No. Okay. So is there like do you guys have questions on it?
Yeah, I have two part B.
That's 2 part D. That's 2 part D.
Well, also part C.
Also part C.
Yeah.
Okay.
Because it seems really easy, but it's also like maybe you want something crazy.
No. Remember how I said simple is good? Simple is good.
Okay. Well, that makes sense.
Then maybe that's it.
Okay.
So, my Saturday class had a lot of issues. You guys don't seem to be having as much, but I also am kind of feeling that you haven't really gotten deep enough to know that you're going to have issues. Yeah.
Well,
Say everybody. So, C and D.
okay.
So we're going to talk about, I'm going to give you guys some hints and tips and smart advice. I'm going to tell you that I gave them some dumb advice, and I'm going to give you guys some smart advice. But one of the things, I've had several people in my office, I've had a lot of emails about this. So my plan was to extend the deadline for this one, at least until tomorrow evening. If you still need help after tomorrow, because tomorrow's Thursday, I have office hours tomorrow, so please do it tonight. If you turn in, the faster you turn in, the faster I get it graded, the faster I get it back to you, if you want the grade for studying purposes.
Do we know the issues that they face?
Yeah, we're going to talk about them here in just a second. Yeah. So, we're going to do this example, and this example should help some of the problems, and then I'll talk about the 2 specific issues that they had. So, I needed something to talk about with this one coming up. Alright, so, we'll come back to assignment 5. What I'm going to do right now is I'm going to open the data. I'm going to open the shoppers, servers, assets. So I'm opening the shoppers data set. So here's our Heavenly Chocolates data set. We have our customers, and we have 50 customers. We have the day of the week they bought their product, we have the browser that they used, the time they spent on our website, the number of pages that they viewed, and the amount spent. And so my question is there a difference in the average amount spent by this sample of customers compared to our in-store average of $60? So, what will we do? What type of, like, what am I asking you to do? Am I asking you to do some descriptive statistics? Am I asking you to do a confidence interval? Am I asking you to do a hypothesis test? What are we trying to do with this question? Probably a hypothesis test. Especially because that's what I'm trying to yes. But here's the question, okay? So is there a difference in the average amount spent by this sample of customers compared to our in-store average? So, my first question could just be, well, what do I need to know? Before I even get to the hypothesis test, what would be nice to know? The average, right? So I could describe, so amount spent, is it a continuous or categorical variable? Continuous variable, so I'm going to the summary statistics. I'm trying to do a little test review. Summary statistics. I'm interested in the amount spent, so that's the variable I need. Really, all I'm interested in is the mean. But if I was interested in the sum, which was one of my other questions, maybe I would click sum. Be careful when you're playing with the maximum decimals, right? We're talking about dollars. 2 decimal places is a good place to round to for most things. If you're going to not round to any decimal places at all, you need to have a really good reason. Sometimes we do have really good reasons, right? When we're talking about the number of people, right? You have 19 people, you have 20 people. You can't have 19.8 people. That number sounds familiar. We don't really need percentiles. Just for fun, let's do some confidence limits. And we're going to stick with our nice, trusted 95%. I don't know that I need any pictures or anything, really. Okay, so I'm going to run this. So what I know, right? I know that my population mean, the thing that I'm assuming is $60, and my sample mean is $68.13. So if I just ask you based on the point estimate, would you say this sample has the same higher, lower average than what we have for our in-store average? Higher. Okay. What about if I didn't just do a point estimate? What if I went and did a interval estimate? Right. So if all I had to do was, here's the mean for my population. I'm going to say that's $60. Here's the mean for my sample. 13. So our claim would be higher. What if we looked at the confidence interval? $8.94 to $77.32. Now what would your conclusion be?
60's in there. It's below it.
Alright, so 60 does actually fit in my confidence limit, or my confidence interval. So if 60's in there, then is there a chance that there's no difference between our sample and the population? Yeah. So here, there's a chance there's no difference.
If the alpha is 0.0.
Yes, assuming that we're looking at a 95% confidence interval, so an alpha level of 0.05. Well, let's go ahead and take it that step farther. Let's go ahead and do the statistical test. Okay? So, I'm going to do two things. I know this, but I never thought to do this. And my Saturday students were like, can you like take a screenshot of that and just add it to the PowerPoint? I was like, that's kind of a cool idea. I'll shrink it and make it fit later. There we go. So now the stuff we're doing, you can actually have. Is that helpful or not waste my time?
Very helpful.
Helpful. Okay. All right. Okay. So going back. So now if I go back to my statistics. So now let's do that hypothesis test. Okay. So we're going to do a one-way t-test and one sample t-test. Okay. We're going to take a sample mean, compare it to a population mean. Two ways we can do this. If you use the tutorial, I'm going to do it the tutorial way first, and then I'm going to do it my preferred way second. Okay, so if you follow the tutorial, what it tells you to do is we're still going to describe, and we're going to go to distribution analysis. And once in the distribution analysis, we're going to need amount spent. And then you go down to tables, the tables option. And in the tables option, you can also get your confidence intervals here. You can get basic measures, which would be descriptive statistics. And then you can also get this thing that's a test for location. So we're trying to find out, does the null hypothesis, our mean, what are we trying to say our population mean is? What mean are we comparing it to? 60. So we're going to change that to 60. The tutorial actually tells you to uncheck these boxes, but I'm going to leave them just so we can see what else there. Then I'm going to click Run. So it looks a little bit different. We're using a different procedure to get the output. But we have the mean, standard deviation, basic information. We have confidence limits, so we still have our confidence interval. So right here, the 58.94 and the 77.32. So we got that information. And then for our hypothesis test, this student's T is what we're going to be looking for. So before we get there, let me take one step back. Let's actually go through the steps of our hypothesis test. So we need to figure out what is our null hypothesis and what is our alternative hypothesis. So what do we want to claim here?
Population. Well, if there's a difference between the sample and the population.
So we're trying to figure out, is there a difference between the sample and the population? So we're talking about means, so I know I'm going to have, this is my way of writing the Greek letter, mu, I try. And then we know we're going to use 60 over here. So the question is, what symbols are we going to use in the middle?
Equal to not equal and not equal.
I've heard equal and not equal, but I also heard greater than and less than. How many vote for equal and not equal? Okay, let's start there. How many vote for the sample is greater than the population? How many aren't sure yet? Okay, so let's say that we're going to say that they're just different, right? Because when we started out, we didn't know what the mean for the sample was. And the question itself, what does the question ask? Just, is there a difference? It doesn't say one way or the other way, right? So had my question said, is the average amount spent by this sample of customers greater than compared to our in-store average? Okay. Making sure we're on the same page. Okay, so we have our null and we have alternative. Yes.
Right, so the mean symbol there, is that referring to the sample mean?
Yes. So,
Not the population.
so anytime we're talking about hypotheses, right, we always are trying to, we take a sample and we refer out to the population. So our hypothesis is about the population.
Oh, okay.
The data that we'll use is the sample. But when we write our hypothesis, we're trying to make the inference about the population.
Okay, so we'll always be the possible.
So we always use parameters when we're writing known alternative hypotheses. That's a great question. Alright, so there's number one. Number two, I have to tell you what the alpha level is. And since we picked 95% with our analysis, we're going to keep it as an alpha of 0.05. And everybody's good about that relationship.
So if you changed it, if you wanted a like 0.01 alpha
Yes.
level, would you change your confidence level?
Yes. Right, so if we went back to modify this test, now that being said, if I want to be able to compare the confidence levels, like if I want to be able to compare confidence intervals, then yes, I would change my confidence levels. Let me try. Let me say that. So, if when I'm in this table and I am going to produce the basic confidence interval, if I want it to be able to match my hypothesis test at an alpha level of 0.01, then yes, I would need to change this. Okay. However, once I do this, this test for location does not take an alpha level into account. So that's kind of the question. So do you have to change the confidence interval? No, you do not when you're doing a hypothesis test. Because you are the one who has the alpha level, and when you're talking about these hypothesis tests down here, they do not factor the alpha level into their account, into their equations at all.
So that's just something for us to have, compare it once we have the p-value.
Right.
Okay.
So if you want to be able to compare it to the confidence limits up here, the confidence intervals, then you want it to match. But if you're going to ignore these confidence intervals and you don't want it, then it doesn't matter if you change it or not. Is that your question? Okay. So, yes and no. No, it doesn't matter for the actual hypothesis test. Yes, it matters if you're doing what we're doing and looking at point estimates, interval estimates, and how does it compare. Yes. Okay. Good. Okay. Step one, step two, step three says, what is our test statistic? And we get that from right here. Our test statistic is 1 point, so I'm going to round it to decimal places, 1.78. Step 4 says, what's our p-value? Our p-value from right here. And you'll notice that the p-value says it's the probability that we're greater than the absolute value of t. What that absolute value is telling you is that it's the plus and minus. That absolute value is telling you that it's a two-tailed test. Okay. If I told you it was the default, that's how I know it's the default. So our p-value is 0.0818. So if we go back to step 5, we get to compare. We get to compare our p-value and our alpha level. So we have an alpha level of 0.05, we've got a p-value of 0.0818. Which one's bigger? Our p-value is greater than our alpha level. So what's our statistical conclusion? Fails to reject. The null hypothesis. Yes.
Could you, this may be like a really big question, but could you explain like that process like in words? In the sense like, okay, I understand like, okay, the p-value is less than our alpha that we reject. So, okay, that makes sense. But like, what does that mean as far as like, okay, what do the numbers mean? Does that make sense?
Yeah, so basically what we're saying, right, so our alpha level is our willingness to make a type 1 error, right? So that's how we choose our alpha level. What our p-value is telling us, that's the probability that if our null hypothesis was true, that this sample mean would occur in another population, or in another sample. So what I'm saying is, so like I'm willing to make I've got a 5% chance that I'm willing to make a type 1 error.
Okay.
The p-value is telling me that really 8% of the time I would probably be making a type 1 error. I'd be rejecting my null when I shouldn't be.
Okay.
So this isn't quite a technical explanation, but
Yeah.
trying to put it together for you.
Yeah.
That's basically what we're looking at. So the probability that we're our cutoff of saying, I'm willing to make this mistake this many times, if our probability doesn't meet that, then we're going to reject our null, or fail to reject our null and be like, you know what, let's be safe, let's keep our null hypothesis.
Because this, sorry, I'm just trying to.
No, you're good.
So this.
I'm going to have
is
these
the
guys
same-
talk to you too. Some of these guys talk to you too, so.
Okay. Because this is saying, okay, 8% of the time I'm going to make a type 1 error, but I'm only comfortable with making a type 1 error 5% of the time.
That's one
So
of the ways
that's
you can
what
look at it.
Could you draw the curve in the shaded
Sure.
area?
So picture kind of what we're looking at here. All right, so we said it's normally distributed. That's one of the assumptions we made. We didn't check it, but we're assuming it. And so I'm saying that my population proportion, or my population mean, what I'm testing it against is 60. What I actually got was 68. So I'm saying that I've got an alpha, and even though we're looking at an alpha of 0.05, technically, because it's a two-tailed test, I split my alpha like this. And what I've got with that 68, this is telling me that here, this green, is a 0.0409, I guess. Because it's a two-tailed test, I've got it all together and everything's good. I'm not worried about it. But that's kind of what we're looking at. So in a normal population, then I would expect, by chance, that that's going to happen 5% of the time. But I'm only okay with it happening 2.5% of the time.
Excuse me.
Yes.
Just confirm what I understand. So when we say the probability, the p-value is 0.08, that means that I have that tells me the probability of finding a mean which is 60 in some other population. Is that true? And since I have the significance level as 0.05 and p-value being probability is higher, that I will find a mean 60 in some other population, some other sample. Therefore, I'm failing to reject the null hypothesis, so I'm retaining the mean as 60.
Right. So what we're saying is, I don't have enough evidence. Right. So if we go to the next step, and we'll come back to where we're at. If I go to the next step and say, I'm failing to reject my null hypothesis. So if I fail to reject my null hypothesis, that means I'm keeping it, right? So I don't have enough evidence to say that 60 and 68 are significantly different from one another. In this context, given these scenarios, given this sample size, given all of the information that I don't have enough evidence to say that 60 is statistically different, or 68 is statistically different from 60.
68 of this sample is different from the population.
Right. So yes, this is helping.
Yeah.
Okay.
Okay, I'm very grateful that the graph was drawn because my question was related to that. In the sense, I understand why academically we are doing this, but after we find the confidence interval and we have that graph or at least the values, do we actually need to do a hypothesis testing? Because if your alpha is 0.05, you're doing a 95% confidence interval, and the mean is population mean is lying within that range. Doesn't that already answer the question? Do we need to do the test?
It depends. So, do you guys hear his question?
Yeah.
Right. So his question is that if you do it the confidence interval approach, right? The confidence interval approach, what that does, it will give you the same conclusion as the conclusions of the hypothesis test. So if all you're looking at is just are they different or are they not, then yes, one, the other, it doesn't really matter. The thing that you get with the addition of the statistical test is it helps you with the one-sided, the one-fill test. You can do that with confidence intervals, but it gets a little more confusing. It also helps you with the probability, right? So if for some reason, like my population mean was 50, right? It would be outside my it would be outside my confidence interval. I could say that there's a difference, but I wouldn't necessarily know how big of a difference. So here, when we do the probabilities, now we're getting more information of saying, they're really close, or no, these are definitely very different from one another. Does that help? So, yes, no, yes. Do you have to? No. Academically, yes, because I'm making you. But this is also the foundation of when you're just looking at a group compared to a population, it's not too bad. When we start to do two groups compared to each other, then we can still do the confidence limits, the confidence intervals, but it's a little bit different. When we start comparing multiple groups to each other, then it gets even more complex. And so then you start where, like right now, the confidence interval versus hypothesis test, yeah. But later, the statistical tests kind of take off as a more prominent way to do it. You answered your question, not answered it? More
yes,
questions?
I think I just still need to understand more like the type 1 error. As far as, it's just, I understand that, but then like, just the language of failing to reject the null, like how, I don't know, I think I'm still kind of not connecting. So
the big idea with the whole failing to reject, your book says accept, I don't like accept, I like fail to reject, but they're the same thing. So failing to reject a null is really the idea of, do I have enough evidence to say that these two values are different? Right, so when we looked at 60 and 68, initially you said, yeah, 68 is higher. And then we did our confidence interval, like, well, 60 is actually in our confidence interval, so maybe it's not. And so now we're getting to the statistical test piece, and we're saying, actually, it's like, I don't have enough evidence, given the criteria that I've used here, to say that 60 and 68 are statistically different from one another. So if I don't have enough evidence, that p-value, that probability that I'm looking for, or that I've calculated, isn't as extreme as what I'm okay with, right? Accepting that for that type 1 error. Then that's where I failed to reject my null hypothesis. So that I don't have enough to reject it, because that's really what we're testing. The whole idea is, you can think of the null hypothesis as like the status quo. Right? What's going on, what's existing, what's happening right now is the status quo. So can I say that my sample is different from the status quo? Like, no, I don't have enough evidence to reject the status quo, so I've got to stick with it. Does that help?
I spent a lot of time understanding failing to reject and then finally concluded retain is a better, much simpler way to put it. Do I retain the null hypothesis, that is the status quo, or I embrace or I reject?
Yeah, you could use retain as another word. Yeah.
And then I reject HO and then replace it with the alternative.
The alternative. Exactly. Next.
Failing to reject was like negative of.
That's what I say, people are thinking you kind of
positive.
get that whole double negative
Yeah.
feel. So yeah, if you don't like fail to reject, you can say retain the null hypothesis, like keep it.
Yeah.
That's really what's going on. So if we did step 6, finish it out, and then we'll take a break. Step 6 would be, there is not enough evidence you can say this a lot of different ways to support the claim. Average, beside this, amount spent. Line is different than the average amount spent in the store. That's fine. The last thing I want to show you before we take a break would be, so this is great. Do you have any questions about this before I move on? So this is the way, like I said, if you went through the tutorial, this is what it's going to show you to do. Other option is if I start out with my data, and I still want to do this hypothesis test, if you analyze, right, because really what we're trying to do now is we're trying to analyze our data. So if you go to Analyze, and then ANOVA, there's a t-test. So you can use the t-test option. And I know my writing's here, so work with me on this one. There's 2 samples, there's paired, and there's 1 sample. So for the next 3 weeks, so we've done a 1 sample. Next week we're going to talk about 2 samples. And the week after that we're going to talk about paired. So for 3 weeks we're going to live with these t-tests. So instead of having to know about the distribution, you could just go here to the 1 sample. Then you go to the data, same idea, we're going to choose amount spent, thank you. We're going to go to analysis, and here's where we get to plug in what our null hypothesis is. 60. And if we run this, and the reason I left the writing
Make sure that it's the same.
is to make sure they're the same. So if you look at the writing, this is what we're looking at. Okay. Our t-value is 1.78, and our p-value is 0.00 or 0.818. So you get the same information, just in a different output.